So we're going to start part 2 here, and we're going to take a look at the short video. We're not going to look at the whole thing here.
At this point, since we're only dealing with memorizing any specific pattern we've seen, to understand the world around you.
Alright, see if I can find where we were going to start.
A great
it here.
example
Here
of someone who was able to see the mathematical patterns around him is Carl Friedrich Gauss. In 1787, young Carl was a 10-year-old student in Braunschweig, Germany. The pattern that was perhaps most apparent in his class was the tedious repetition of a dismal life, toiling over slates in a drab, low-ceiling classroom, and avoiding beatings from the abusive teachers. There was an instructor at the school by the name of Büttner. Although he enjoyed intimidating his students, Büttner often found that teaching involved too much work. He therefore devised ways to keep his students busy for hours on end while he sat back to relax. On one occasion, as the story goes, he gave his class the task of adding together all the numbers from 1 through 100. This, he had hoped, would earn him a relaxing afternoon of watching students tap away at their slates. He had barely finished his instructions when his student, the young Carl Friedrich Gauss, stood up from his desk, walked up to the front of the room, and turned in his slate on Büttner's large desk with an offhanded, "There you go." Young Carl sat quietly for the rest of the afternoon as his fellow students finished their addition, and Büttner planned how he would beat his arrogant student for avoiding his classwork. One by one, the other students finished and placed their slates on top of Carl's. When all of the slates were turned in, Büttner immediately ripped Carl's slate out from the bottom and looked at it. To his astonishment, he found that Carl had the correct answer, and the only number on his slate was the answer. He had written no calculations whatsoever.
Alright, so we're going to see if we can figure out how he came up with that number. So he was asked to find the numbers, sum the numbers 1 to, I believe it was, 100. So, how did he do that? Well, what he realized is, let me write this out, 3, 97, 98, 99, and 100. If you take the first term and the last term, you get 101. The second term, second to the last, you get all these sums of 101. And so what he realized is this formula that's on your next slide. To sum a series, you take the first one you need and the last one. So that's like taking the 1 and the 100, the 2 and the 99, and you're always going to get that same sum, the 3 and the 98, and then, but you only have n plus 2 of those. So that's how he got it. So 100 over 2, there was 50 sums of 101. So when we're asked to find the first 50 terms, we need our first term, which is 4, and our 50th. And, well, our rule for this, we start with 4 plus n minus 1. Our difference is 3, but n is, we want our 50th. So let's see, what is 4 plus, dropped the pen there, sorry about that. So what is 4 plus, it would be 49. 49 times 3, so we end up with 151. Okay, and let's double check. So 49 times 3, 27, carry the 2, 12. Yep, so 151 is our 50th. So we do 50 over 2 times 4 plus 151. So we have 25 times 155. So 25 times 155. And we end up with 3,875. So if we take a look at one more here, let's see, find the sum of these. Well, we need to figure out first how many terms there are. So what's our rule? A sub n equals a sub 1 plus n minus 1 times our difference. Well, we know we're going up by 7, so 141 equals negative 6 plus n minus 1 times 7. So 141 equals negative 6 plus 7n minus 7. So add 13. So 154 equals 7n. So 154 divided by 7 is 22. So we're summing 22 terms. So our first term is negative 6. Our 22nd term, so our first term plus 22 minus 1 times 7. So negative 6 plus 21 times 7, 141. So we have 22 over 2 times negative 6 plus 141. So that would be 11 times negative 6 plus 141, and we end up with 1,485.